Hello everyone, how's everyone doing today? I hope you have a decent weekend so far. Okay, so this stream will be the beginning of a series, I don't know how long series, but series about Git. Not GitHub, not any tooling around Git, just Git and its CLI and how it works. So maybe I'll start a little bit of motivation. Why do I even start that? Because there are so many tutorials and whatnot. So first of all, this is series documenting me just learning. And if you want to join, go ahead. Maybe you'll learn something. And my motivation is that I've used Git for years, but I always used some kind of tools, some kind of visual tools to deal with Git. Mostly in my case, it was Git Kraken. I mean, I really love the tool. It makes it easy, quick for me to do everything. I need to type too much, and I can do advanced stuff without even thinking about it, right? So I understand what Git is doing behind the scenes roughly, but not a lot. And recently I'm thinking like, you know what? I don't care that, I use a paid tool or whatnot, but what I care about is that, this is such an integral tool that is basis of so many things. And I only know it a little bit. I have an idea what's going behind the scenes, but I don't really know. So how can I be really good at using this tool without understanding it properly? And now if I would ever want to consider, let's say, trying JJ or something of the sort, currently it uses Git, so kind of you need to know what Git is doing behind the scenes to understand the new tool before, years until it goes its original and all that stuff. So yeah, the idea is to learn it in depth for my own sake, to just understand what the tool is doing. And by any chance also get comfortable with command line tools, right? So I don't need a visual tool or scratch my head or ask AI, hey, how do I do this? Just know the tool. And hello, Taras, how are you doing? Taras says, it was one thing I wanted to do is to learn Stack's competitors. Well, this will be purely Git, yeah. So how am I going to go about this? I give it a thought, and there are, so many sources of learning Git. But I figured I want something comprehensive, something that will teach me everything about Git that I would ever need to know, unless I'm working on Git or whatever. And what I found out is that, let me share my screen, is that apparently, this is the official Git website. So apparently, there is ProGit by Scott Chakan, and Ben Strobe. And, you can buy it or you can read it online for free. And this is regarded apparently as the manual for Git. Taras says, no Git Kraken? I will be still using Git Kraken most likely, but I would like to get comfortable with what happens behind the scenes. So, I kind of am aware a little bit more. And in case I'm stuck without Git Kraken or something, I'm still productive. And I don't have to think too much. Because one thing is to learn the CLI, okay, you do this and this and that, some commands. But what do they do really behind the scenes? That's what matters. What if I break something, and how do I fix it? Why did it break? All that stuff. Okay, and then, you go into more advanced, maybe work trees, doing all your rebasing. What are the differences between this and that, and some other random stuff. I want to learn in depth. So I figured maybe we can read it online, and I don't know how long the book is. I literally opened this page, looked at, okay, we have some getting started, which is some history, and maybe starting out. We have Git basics of usage. I hope this will start explaining some things, maybe, Git branching, Git in a server or whatnot. But we have then besides some tools and customizing. Again, I don't know how in-depth it goes. But then we have Git internals, plumbing, how objects references work, all that fun stuff. I want to learn about it, and as we read the book, we'll learn what is worth reading, what is not. And Tara says, work trees suck. Oh well. I guess I'll learn about that. And ProGit is cool. That's awesome. I'm glad you're implicitly recommending the book. And see ya. Alrighty. Okay, so the entire ProGit book, written by Scott Chacon and Ben Straub, and published by a press, is available here. All contents are licensed under Creative Commons Attribution Non-Commercial Share Alike 3.0 license. We can buy it also on Amazon in the print. The version found here has been updated with corrections and additions from hundreds of contributors. Okay, and it has its own GitHub repository. That's awesome. Okay, so let's go to getting started. Okay, this chapter is short. Cool. So maybe it's gonna go relatively fast. Big pictures. Wow, this is a big picture. We'll see how it goes. All right, so if you're new to this channel, I will be mostly reading and then doing some experimentation, but it's the beginning of the book, so probably will be mostly reading. And wondering aloud, plotting theories. Alrighty. This chapter will be about getting started with Git. We will begin by explaining some background on version control tools, then move on to how to get Git running, on how to get Git running on your system, and finally how to get it set up to start working with. At the end of this chapter, you should understand why Git is around, why you should use it, and you should be all set up to do so. Okay? I mean, I don't need convincing. I know that it's flawed, but at the same time, it's the, I don't know, lingua franca of version control currently. Alrighty, about version control. What is version control and why you should care? Version control is a system that records changes to a file or a set of files over time so that you can recall specific versions later. For the examples in this book, you will use software source code as the files is being version controlled. Though in reality, you can do this with nearly any type of file on a computer. Yep. And you have, more specialized things than Git itself that are all maybe for gaming or something, and they work a little bit differently because, oh, this works with larger files. This one focuses on binary, this one focuses on art, whatever. But we'll go with generic Git. If you're a graphic or web designer, you want to keep every version of an image or layout, which you would most certainly want to, a version control system, as in VCS, is a very wise thing to use. It allows you to revert selected files back to a previous state, revert the entire project back to a previous state, compare changes over time, see who last modified something that might be causing a problem, who introduced an issue and when, and more. Using a VCS also generally means that if you screw things up or lose files, you can easily recover. In addition, you get all this for very little overhead. Alrighty. Local version control systems. Many people's version control method of choice is to copy files into another directory, perhaps a timestamp directory if they're clever. This approach is very common because it is so simple, but it is also incredibly error-prone. It is easy to forget which directory you're in and accidentally write to the wrong file or copy over files you don't mean to, all that fun stuff. So, to deal with this issue, programmers long ago developed local VCSs that had a simple database that kept all changes to files under version control, right? So we have our local, oh, this is a picture. We have our local computer, and we have our version database. We can have our file. We can, I guess, check it out to, let's pull the version 3. Bam, and there's our version 3 of the file. And the database just keeps all of them. So the local version control diagram. One of the most popular VCS tools was a system called RCS. Never heard of it, which is still distributed with many computers today. RCS works by keeping patch sets, that is, the differences between files, in a special format on disk. It can then recreate what any file looked like at any point in time by adding up all the patches. Lovely. So this lives only on your computer. It's just local. And then we have an upgrade, centralized version control systems. The next major issue that people encounter is that they need to collaborate with developers on other systems. To deal with this problem, centralized version control systems, CVCSs, were developed. These systems, such as CVS, Subversion, and Perforce, have a single server that contains all the version files and a number of clients that check out files from that central place. For many years, this has been the standard for version control, right? We have one shared repository and every developer connects to it. So you pull, let's say, copy of that onto your computer, but there's one server you connect to. So I guess for a regular user of GitHub, it might look like this is the thing, right? Oh, I just have my repository on GitHub, I pull from it, somebody else pushes to it, right? There's that mechanism that there's this central thing. And I guess most people who use Git don't use this decentralized thing. They use it as a centralized thing. So it's kind of funny to think about it. This setup offers many advantages, especially over local VCSs. For example, everyone knows to a certain degree what everyone else on the project is doing. Administrators have fine-grained control over who can do what, and it's far easier to administer a CVCS than it is to deal with local databases on every client. Exactly. However, this setup also has some serious downsides. The most obvious is the single point of failure that the centralized server represents. If that server goes down for an hour, then during that hour, nobody can collaborate at all or save version changes to anything they're working on. If the hard disk the central database is on becomes corrupted and proper backups haven't been kept, you lose absolutely everything. The entire history of the project except whatever single snapshot people happen to have on their local machines. Local VCSs suffer from this same problem. Whenever you have the entire history of the project in a single place, you risk losing everything. Alrighty, so then we enter the distributed version control systems. This is where distributed version control systems, DVCSs, step in. In a DVCS, such as Git, Mercurial, or Darks, clients don't just check out the latest snapshot of the files, rather they fully mirror the repository, including its full history. Yep, everything. Thus, if any server dies and these systems were collaborating via the server, any of the client repositories can be copied back to the server to restore it. Every clone is really a full backup of all the data. Here we go, server computer, version database, we have all three versions, and whenever we pull it, clone it, we get literally everything, all the versions. So, furthermore, many of these systems deal pretty well with having several remote repositories they can work with. So you can collaborate with different groups of people in different ways simultaneously within the same project. This allows you to set up several types of workflows that aren't possible in centralized systems such as hierarchical models. So that's something I don't have much experience with, where, what I'm used to is, okay, my stuff is somewhere on this centralized server called Git. Sure, I pull my entire repository, I can do whatever I want with it on my computer, and then synchronize it with GitHub sometimes. But I never did other way, like, oh, I have two remotes, or push that to somebody else's repository or something. I guess the closest thing is when you need to clone a repository, fork a repository to to make some changes so that you can submit a pull request to the original repository. I guess that's probably using this kind of style, but it's all abstracted away in my case. Okay, so that was the first chapter, or like sub-chapter. Okay, getting started. A short history of Git. It is short, lovely. As with many great things in life, Git began with a bit of creative destruction and fiery controversy. The Linux kernel is an open source software project of fairly large scope. During the early years of the Linux kernel maintenance, as in from 1991 to 2002, changes to the software were passed around as patches and archived files. In 2002, the Linux kernel project began using proprietary DVCS called BitKeeper. In 2005, the relationship between the community that developed the Linux kernel and the commercial company that developed BitKeeper broke down, and the tool's free of charge status was revoked. Ooh. This prompted the Linux development community, and in particular Linus Torvalds, the creator of Linux, to develop their own tool based on some of the lessons they learned while using BitKeeper. Some of the goals of the new system were as follows. Speed, I guess the other one was slow. Simple design, the other one was complex. Strong support for nonlinear development, thousands of parallel branches. Fully distributed, and able to handle large projects like the Linux kernel efficiently. Basically, speed and data size. Alrighty. Since its birth in 2005, Git has evolved and matured to be easy to use and yet retain these initial qualities. It's amazingly fast and very efficient with large projects. And it has an incredible branching system for non-linear development, as in, see, Git branching. Awesome. I like that short history. I was expecting like, oh, it's going to be one of those books where we have like 30 pages of history that nobody really cares about. Okay, great. Wow, we are storming, getting started. What is Git? So what is Git? What is Git in a nutshell? This is an important section to absorb because if you understand what Git is and the fundamentals of how it works, then using Git effectively will probably be much easier for you. There we go. I need that. As you learn Git, try to clear your mind of the things you may know about other VCSs, such as CVS, Subversion, or Perforce. Doing so will help you avoid subtle confusion when using the tool. Even though Git's user interface is fairly similar to the other VCSs, Git stores and thinks about information in a very different way. And understanding these differences will help you avoid becoming confused while using it. Okay, so we have snapshots, not differences. Okay. The major difference between Git and any other VCS, as in Subversion and Friends included, is the way Git thinks about its data. Conceptually, most other systems store information as a list of file-based changes. These other systems, CVS, Subversion, Performs, and so on, think of the information they store as a set of files and the changes made to each file over time. This is commonly described as delta-based version control, right? So check-ins over time go to the right. So version 1, we have file A, file B, and file C. Version 2 looks like we have modification to file 1, and this is again modification 1, 2, and we do that. Modification number 2. So in version 4, we have the second version of the file A. In file B, here we have this like first change to that one and whatnot. All right. Storing data as changes to a base version of each file. All right. Git doesn't think of or store its data this way. Instead, Git thinks of its data more like a series of snapshots of a miniature file system. Okay? With Git, every time you commit or save the state of your project, Git basically takes a picture of what all your files look like at that moment and stores a reference to that snapshot. To be efficient, if files have not changed, Git doesn't store the file again. It It just links to the previous identical file it has already stored, all right? Git thinks about its data more like a stream of snapshots. Okay, I see. So basically, if we have version 1, file ABC, version 2, we have A1, I guess this one changed, and this is still B, the original B, and this is the new C1. Version 3, this one doesn't change, this one didn't change, only C2 changed, and so on. We always have information about all the files in form of some kind of links or maybe changes, but that's pretty much it, okay? So, all right, I can see that. The only problem I can see is like, what if you have like hundreds of thousands of files? Every time you commit, you need to create a snapshot that has 100,000 links? Don't know. That's a good question. That's an answer I would like to get by the time I finish the book. So this is an important distinction between Git and nearly all other VCSs. It makes Git reconsider almost every aspect of version control that most other systems copied from the previous generation. This makes Git more like a mini file system with some incredibly powerful tools built on top of it, rather than simply a VCS. We'll explore some of the benefits you gain by thinking of your data this way when you cover Git branching and Git branching. Okay, so I guess this will be nice because we are kind of storing like pointers at data, and I would expect that because we store those pointers, we can simply, instead of doing lots of file operations or whatnot when we're storing stuff, we just kind of follow the pointers, manage them, just point at stuff instead of, I don't know how to describe it. I guess you can some kind of non-destructively rearrange stuff. I don't know. I'm looking for words I don't have right now. So nearly every operation is local. Most operations in Git need only local files and resources to operate. Generally, no information is needed from another computer on your network. If you're used to a CVCS where most operations have that network latency overhead, this aspect of Git will make you think that the gods of speed have blessed Git with unworldly powers, because you have the entire history of the project right there on your local disk. Most operations seem almost instantaneous. For example, to browse the history of the project, Git doesn't need to go out to the server to get the history and display it for you. It simply reads it directly from your local database. This means you see the project history almost instantly. If you want to see the changes introduced between the current version of file and the file a month ago, Git can look up the file a month ago and do local difference calculation, instead of having to either ask a remote server to do it or pull an older version of the file from the remote server to do it locally, right? Everything's already on your computer. This also means that there is very little you can't do if you're offline or off VPN. If you get on an airplane or a train and want to do a little work, you can commit happily to your local copy, remember? Until you get to a network connection to upload. If you go home and can't get on your VPN client working properly, you can still work. In many other systems, doing so is either impossible or painful. In Perforce, for example, you can't do much when you aren't connected to the server. In Subversion and CVS, you can edit files, but you can't commit changes to your database because your database is offline. This may not seem like a huge deal, but you may be surprised what a big difference it can make. So, this is something that some companies actually prefer because maybe you're working with sensitive data. to some extent, very sensitive code base or something, and you basically don't want to allow employees outside of home to actually browse the history. Maybe they should have only the current state. I believe some companies even go to an extent that you can't really have local copy of entire repository on your computer. So yeah, there are different extents of that. But for something like open source or like most normal projects, yeah, Git gives you superpowers. So now we have Git has integrity. Everything in Git is checksummed before it is stored and is then referred to by .checksum. This means it's impossible to change the contents of any file or directory without Git knowing about it. This functionality is built into Git at the lowest level and is integral to its philosophy. Okay, you can't lose information in transit or get file corruption without Git being able to detect it. Awesome. That's very nice. That was just from the ground up. The mechanism that Git uses for this checksumming is called as a SHA-1 hash. This is a 40-character string composed of hexadecimal characters 0 to 9 and A to F, and calculated based on the contents of a file or directory structure in Git. A SHA-1 hash looks something like this. Bam. You will see these hash values all over the place in Git because it uses them so much. In fact, Git stores everything in its database not by file name, but by the hash value of its contents. Okay? Git generally only adds data, all right? When you do actions in Git, nearly all of them only add data to the Git database. It is hard to get the system to do anything that is not undoable or to make it erase data in any way. Sure. For a person like me that usually uses some kind of interface, it seems like it's easy to delete stuff. It's easy to undo something. But something tells me that this is only like on a surface, and really behind the scenes, the data is still there. It's just you need to know how to access it. You need to know how to undo something you just did. As with any VCS, you can lose or mess up changes you haven't committed yet. But after you commit a snapshot into Git, it is very difficult to lose, especially if you regularly push your database to another repository. This makes using Git a joy because we know we can experiment without the danger of severely screwing things up. For a more in-depth look at how Git stores its data and how you can recover data that seems lost, exactly, that seems lost. For me, it often seems lost. See undoing things, all right? That's why I like Git Kraken, because I can just hit Ctrl-Z and it just magically undoes things. Okay, the 3 states. Pay attention now. Here is the main thing to remember about Git if you want the rest of your learning process to go smoothly, okay? Git has 3 main states that your files can reside in. Modified, staged, and committed, all right? Modified means that you have changed the file but have not committed it to your database yet, okay? Staged means that you have marked a modified file in its current version to go into your next commit snapshot. And committed means that the data is safely stored in your local database. So yeah, I personally really like that 3-part thing. Let me turn off my phone because I'm getting a bunch of noises. Okay, so again, modified, staged, committed. This leads us to the 3 main sections of a Git project: the working tree, the staging area, and the Git directory, okay? So we can see that we have working directory, staging area, and Git directory. So first, we check out the project. We get it from the repository into our working directory, all right? That's the checkout. From working directory, I guess we make some changes and stage files to the staging area, okay? And then we grab everything from staging area and commit it. And that's pretty much it. Yeah. The working tree is a single checkout of one version of the project. Okay, so working directory or working tree is a single checkout, as in whatever, single snapshot or whatever, of one version of the project. So this is like, we have the single snapshot of a state of the project at the time, and we just load all the files in that state. These files are pulled out of the compressed database in the Git directory and placed on disk for you to use or modify. The staging area is a file generally contained in your Git directory that stores information about what will go into your next commit. Its technical name in Git parlance is the index, but the phrase staging area works just as well. Okay, so this is keyword, the Git index, because I heard about it many times. So people do use it. People do use it. So the Git directory is where Git stores the metadata and the object database for your project. This is the most important part of Git. And it is what is copied when you clone a repository from another computer. Okay? So when you clone an entire Git directory. So the basic Git workflow goes something like this. You modify files in your working tree. You selectively stage just those changes you want to be part of your next commit, which adds only those changes to the staging area, okay? You can even say, even though you modified a bunch of lines in the file, you can say maybe this line, and only that line that will go into the staging area. And then at the end, you do a commit, which takes the files as they are in the staging area and stores that snapshot permanently to your Git directory, all right? If a particular version of a file is in the Git directory, it's considered committed. If it has been modified and was added to the staging area, it is staged. And if it was changed since it was checked out but has not been staged, it is modified. In Git Basics, you'll learn more about these states and how you can either take advantage of them or skip the staged part entirely. Okay, so the thing is that here they're stating that if a particular version of a file is in a Git directory is this, and then if the file has been modified, it's in the staging area, okay? And if it was changed since being checked out and it has not been staged yet, it's modified. But the thing is, you can have a single file, parts of it, as in parts of those modifications in the staged area, and yet another parts in modified. Okay, that's something you can do too. You kind of have, you can use the staging area as like a separate little copy of a file. So, I know this goes in, but maybe I haven't finished this thing yet. So I'm gonna work on this here, and you compare your current working directory with the staged area. You see, oh, I changed this. I'm gonna put this in and that. You can just kind of do that before you get your staging area that I only want to push those changes. So you have, let's say, the same file, both in staged and modified, which are two different versions of the file already. But we'll learn about it more in depth, I guess. So, wow, we just went through 1.3 and we already know a lot about Git, like the basics, right? So now we're gonna go getting started with the command line, all right? The command line. There are a lot of different ways to use Git. There are the original command line tools, and there are many graphical user interfaces, of varying capabilities. For this book, we will be using Git on the command line. For one, the command line is the only place you can run all of Git commands. Most of the GUIs implement only a partial subset of Git functionality for simplicity. if you know how to run the command line version, you can probably also figure out how to run the Git GUI version. While the opposite is not necessarily true, exactly. Also, while your choice of graphical client is a matter of personal taste, all users will have the command line tools installed and available. Yep, in most cases. So we will expect you to know how to open terminal in macOS or command prompt in PowerShell in Windows. Seriously? The book about Git that was created for Linux has no mention of Linux. Unless because if you're using Linux, they're already assuming like you know how to open terminal, right? If you don't know what we're talking about here, you might need to stop and research that quickly so that you can follow the rest of the examples and descriptions in this book. Oh my. Okay. Wow, we're going straight through installing Git. So installing Git. Before you start using Git, you have to make it available on your computer. Even if it's already installed, it's probably a good idea to update to latest version. You can either install it as a package or via another installer, or download the source code and compile it yourself. Okay, so this book is written using Git version 2. Since Git is quite excellent at preserving backwards compatibility, and recent version should work just fine. Though most of the commands we'll use should work even in ancient versions of Git, some of them might not act slightly different. So let's see which version I have. Let me just do something first quickly. There we go. So we're gonna zoom in and we're gonna do Git version. Okay, we got version 2.50.1. All right. Okay. So we're using version 2. In theory, we're up to date with the thing. So installing it on Linux, yep. So you do just depending on your file system, there's just so many options here. For most of them, it's already installed. On macOS, I won't even attempt that. I don't know how that works on macOS. Looks like you have some kind of graphical installer. And we have installing on Windows. Let me just change this. I'm gonna make it. Oh no, this is wrong browser. Oh, let's leave it dark mode. Because on the Git website, for some reason, when you turn on dark mode, all the images are grayed out as well. It's like they don't want to scare you with white images. Just makes them hard to see. And then we have installer on Windows. Just download it or use something like Chocolatey or Wingit or something. You can get it from anywhere. Installing from source. And some people may instead find it useful to install Git from source because you'll get the most recent version and all that stuff. Or you can do apt-get and all that stuff. Let's just skip that because it's highly depending on, it's just an installation, right? Okay, getting started. First time Git setup. First time Git has set up. Now that you have Git on your system, you'll want to do a few things to customize your Git environment. You should have to do these things only once on any given computer. They'll stick around between upgrades. You can also change them at any time by running through the commands again, okay? So yeah, Git comes with a tool called Git config that lets you get and set configuration variables that control all aspects of how Git looks and operates. These variables can be stored in 3 different places. We have path etc/git config file contains values applied to every user on the system and all the repositories. If you pass the option system to git config, it reads and writes from this file specifically. Because this is a system configuration file, you would need administrative or super user privileges to make changes to it. And then we've got home directory .gitconfig or .config git config file. Values specific personally to you, the user. You can make Git read and write to this file specifically by passing the global option, and this affects all of the repositories you work with on your system. And then config file in the Git directory that is .git/config or whatever repository you're currently using specific to that single repository. You can force Git to read from and write to this file with the local option, okay? But that is in fact the default. Okay, unsurprisingly, you need to be located somewhere in a Git repository for this option to work properly. Okay, so what I'm understanding is by like if you're not inside some kind of Git repository and you will use, let's say I'm in my home directory. It's not a Git repository, it's my home directory. So the moment I will be starting running the Git config, it will be trying to affect the config from the home directory. All right, just overall for the user. If I were inside a Git repository, I would need to basically run it, Git config will try to target this specific only project to maybe, okay, for this specific project, I use different credentials, maybe it's for work or something. It will be defaulting to that specific configuration within the project. And just in case you still want to affect the non-project specific, but your user stuff while you're running Git config inside your project, you just slap on global option and we'll switch it to target the user stuff. And at any point, you can do also -- system, and that will always make those like shared settings for all the users if you need that for some reason. And in my case, I'm just checking because I want to make sure there's no like sensitive data in there in case we'll be editing it. Bum, 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 bum. Okay, looks good. So we can actually, if I'll do LSA, we can see that I have this git config file here. So if we'll just go up to new vim, git config, right? We'll see that we have a nice file here. So we have, without reading more, we can see that we have some aliases like co, br, ci, st, status, commit, branch, and checkout. So it looks like we can define some good like shortcuts for commands to do stuff quickly. We have rebase enabled, I guess, for pulls. For init, we have default branch specified as main, not the old thing with master. User, I guess this is our global user, I guess, unless for this account, which in case you have name and email. And then we have some credentials for some additional things like for GitHub or for Gist, right? Or Gist. And this helper is empty. This helper is pointing at some other configuration file, right? And then we have fetch prune true. So something tells me this fetch prune will actually optimize our database to some extent. Don't know. Something we'll learn about in the future. But okay, let's keep reading. Each level overrides values in the previous level. So values in git config trump those in the system one. On Windows systems, Git looks for the .git config file in the home directory, okay? For most people. It also still looks in a path/etc config, although it's relative to the Microsoft system root, which is wherever you decide to install Git on your Windows system when you run the installer, okay? If you're using version 2.x or later of Git for Windows, there is also system level config at this location, which is, okay, document settings, all users, application data, git config on Windows XP, and C program data, git config on Windows Vista and newer. Wow, haven't heard about the Vista in a while. And this config file can only be changed by git config-f file as an admin. You can view your settings and where they are coming from using git config list show origin. So git config list show origin. Enter. Whoa. So, oh no, it's just different settings and when they're coming from. So in my case, they're all coming from the same file, right? The user git config. If I were to go to, let's say, repository, sure, this one, and run the same command, suddenly, wow, we have way more settings. Some of them are coming from here, but some of them are coming from the git config, right? Which repository that is, remote origin, all those things. Okay, all right. Cool. We learned something. Wrong button. There we go. And let's just go here. There we go. So your identity. The first thing you should do when you install Git is to set your username and email address. This is important because every Git commit uses this information, and it's immutably baked into the commits you start creating. Okay, so it basically won't let you change, once you commit with a specific name or whatever, it's gonna stay that way. So you do git config global username and you set the name. So in my case, it's xconti, right? Git config global, although in this directory it's by default because I'm at home, user.name. Okay, so we had those headings, which is the first part, and then a specific setting, which was name in that case. And we specified it in this case, it's gonna be xconti, right? Bam. And then we have the same thing with email, which will be xconti@xconti.tech. All right, and bam. And normally this is the main thing you're doing when you set up new machine. You set up who you are, and that's it. The kind of fun part is that, you can put in whatever you want. So this is not like very secure thing to look at. Oh, who really made this commit? You can type whatever you want. I don't, the email doesn't have to exist, whatever. So, yeah. So the common way is to use it, for example, in some kind of scripts that do some automated stuff for you so that like, oh, this didn't come from me, this came from this automated script, without really creating a separate account with separate login, all the other stuff. Again, you need to do this only once if you pass the global option, because then Git will always use the information for your user on that system. If you want to override this with a different name or email address for specific projects, you can run the command without the -- global option when you're in that project, okay? So if I were to go into this repository again, right? What was it? Git config list show origin. Bam. We can see that in this specific repository, I'm still pulling the username, this, and user email here. But if in this specific place, I'm in repos xconti.tech, I'm going to do, let's say I'm going to change the username to not from xconti, it will be, I don't know, me. I'll just run that. And now when I check the settings, I will see that, where is it? Alias username is me. And it comes from home. Really? Oh, because I had the global flag. Sorry. Oops. So the global one is this. But if I'm going to run it without global, just here, enter, and look at the settings. Now should be that from the git config, username is here. And do we get the local config to specify the user again? Yeah. It's just this to me. Bam. Now shows that this is me. Even though this config still goes here, I guess you need to still understand the, which one is actually in use. All right, if I'm gonna go just list, we're gonna get it twice. I guess whatever's on top is, if we have, notice that it goes first from the global and then everything from the local. So something tells me that it just does that, and then here's like, oh, I already have that set, I'm gonna set it again, and because this was set last, it's gonna override it. All right, so yeah, that's that. And how do I clear it? This reads it. Can I nullify it? It's null. Ha! What the heck? When I list it, oh no, username is null. Great. So I guess I have to edit the, what was the file name? .git/config. So neovim.git/config. There we go. And I don't want this, so I'm gonna just delete those two. And there we go. We should be good. We don't override the default setting in this directory anymore. Okay. Great. We learned something already. I wasn't aware about this hierarchy of settings. So yeah, that's gonna come in handy. Okay. Again, you need to do this here and here. Many of the GUI tools will help you do this when you first run them. So then we have your editor. Now that your identity is set up, you can configure the default text editor that will be used when Git needs you to type in a message. If not configured, Git uses your system's default editor. If you want to use a different text editor, such as Emacs, you can do the following. Git config global core.editor. Okay, so we have core set of settings in which we have editor, and we can specify Emacs. All right, on a Windows system, if you want to use a different text editor, you must specify the full path to its executable file. This can be different depending on how your editor is packaged. So here they're showing like Notepad++, they need to give a full path. Yeah, multi-installation, not AB bar, no session, no plugin. I guess these are all the settings for the Notepad++ itself. Jeez. So I have a note. Vim, Emacs, and Notepad++ are popular text editors when used by developers on Unix-based systems like Linux and macOS or a Windows system. If you're using another editor or a 32-bit version, please find specific instructions for how to set up your favorite editor with Git. So in our case, we're gonna run and specify it. Git config global, and it will be core editor, and we'll do neovim. All right, bam. Okay, so your default branch name. By default, Git will create a branch called master when you create a new repository with Git in it. From Git version 2.28 onwards, you can set a different name for the initial branch. To set main as the default branch name, do git config global init default branch main, right? Or I could do primary, or I know there are many conventions, but main is actually, I believe, default setting now. It just comes with that. So yeah. And then you have checking your settings. If you want to check your configuration settings, you can use the git config list command to list all the settings Git can find at that point. So here it just shows him the global ones. There it looks like there are no system ones. But if you're within a repository, the ones from the repository will override some stuff here. Okay. Color status, color branch, color interactive, color diff. Interesting. So there's more settings. You might see keys more than once because Git reads the same key from different files. You know, the system one, the user one, whatever, global. In this case, Git uses the last value for each unique key it sees. Exactly. You can also check what Git thinks a specific key's value is by typing git config and a key, like git config username. I would just tell you, oh, for this place, is this. Since Git might read the same configuration variable value from more than one file, it's possible that you have an unexpected value for one of these values, and you don't know why. In cases like that, you can query Git as to the origin for that value, and it will tell you which configuration file had the final say in setting value, right? So git config, show origin, and the setting, right? Or we can do list show origin and it will just show us everything. Okay, this was informative. I like it. Nice first steps. So something tells me we'll start getting, maybe not yet, but okay, just using the help. So getting started, getting help. If you ever need help while using Git, there are 3 equivalent ways to get the comprehensive manual page, the man page, help for any of the Git commands. You can do git help verb. So let's say git help config. Oh, and it just opened man page. Okay. Then we have git config -- help. It goes straight to man pages as well. Interesting. And then we have man git dash config. Interesting, the dash, huh? Wow, there's what the hell? It, I guess, explains all the possible values in the configuration. That file had, at least in this size, a lot of lines. Wow. Okay. All right. For example, you can get the man page from the git config command for the git config command by running this git help config. These commands are nice because you can access them anywhere. Excuse me, even offline. If the man pages and this book aren't enough and you need in-person help, you can try the Git, whatever, Git, GitHub, or GitLab channels on the LiberaChat IRC server. Holy moly. Which can be found at libera.chat, whatever that is. Never heard of it. These channels are regularly filled with hundreds of people who are all very knowledgeable about Git and are often willing to help. Or nowadays, just ask your chat, your favorite chat. They will probably know the answer very well. In addition, if you don't need the full-blown man page help, but just need a quick refresher on the available options for a Git command, you can ask the more concise help output with the -h option, as in git add h. Oh, so there's difference between git config -- help. This shows me an entire man page. If I'll just do -h for low effort, I'm gonna get rewarded with lower effort results. Ooh, that is very unexpected that these actually have different behavior. Huh. Interesting. Git config list, git config get, set, unset. Oh, nice. Rename section, remove section. You can rename entire section. Maybe if you want to temporarily disable it, you give it some weird name or something. Very interesting. Config edit and file option, get config file option, get colorable name. What the heck? Well, there are options, that's for sure. Yeah, git add age, and this is nice. Really? Git add age. Yeah, okay, so we get that nice result. Okay, cool. A little bit different, but yeah. Next. And this is the summary of getting started. All right. So summary, you should have a basic understanding of what Git is and how it's different from any centralized version control systems you may have been using previously. You should also now have a working version of Git on your system that's set up with your personal identity. It's now time to learn some Git basics. Alrighty, so if we're starting a new chapter, oh, the drunken alcoholic, hello. Use TLDR for easy help topics. What do you mean TLDR? Git config TLDR? Or this is like a separate command, separate tool. TLDR Git. Oh, TLDR help. What the hell is that? Python command line client for TLDR. Does it fetch it from somewhere outside of my computer or something? This is interesting. Never heard of TLDR. You can TLDR just about anything. Do I have to have this thing installed? TLDR Git Kraken. Not available. TLDR Misa. Okay, we've got Misa. All right, this is fun. Yay. Interesting. Because man pages kind of suck. Very interesting. TLDR version? Client specific. So it's a client. So something tells me this fetches it online, right? And Drunken says you already have it installed. You already, yeah, I know I have it installed, but how does it work? Does it fetch it from somewhere online? Because there's the delay, and apparently it knows about everything, so I guess it fetches online. Especially that it says it's a client. TLDR. How about that? Display simple help pages for command line tools from the TLDR pages project. Okay, so we have now the language and list options are not required. Okay. More information, go here to GitHub, print the TLDR page for something, print the TLDR page for a specific subcommand. Maybe you want it in a different language. Let's do TLDR. Oh, wait. Language. Polish. Oh, PL, I guess, is the language. What is the code? Print the TLDR page for command in a given language. If available, otherwise fall back to English. We don't have the codes. I guess let's do PL and do TLDR. Okay, we have Polish, look at that. Wyświetl proste strony pomocy dla narzędzi wiersza poleceń z projektu TLDR Pages. Uwaga, opcje Language i List nie są wymagane przez specyfikację, ale większość klientów je implementuje. There we go. That's fun. And then Drunken says, yeah, online database, but I think it might store local. I guess once you download it, if all around is the same, it's instant. So yeah, it's cached. Okay, this is fun. We can do platform, update the local cache of TLDR pages. So from time to time, you can just update and all the stuff you keep looking up, it's going to update. List all pages for current platform and common. Cool. So there's like open source project, I guess, for all that stuff. thank you for that tidbit. And now that we go to the next section, I'm just gonna take a short 2-minute break and I will be right back. All right, I'm back. That was probably less than 2 minutes. And the drunken says, I just find TLDR easier to read. That's why I mentioned it. Yep, again, thank you for that great tidbit. And I need to go on a tangent, and every time I take like a little bathroom break or something, I just put in the main screen and it just, somebody comes in, it's like, what's going on? I feel like I need to make a little screen that I will be back or something. So maybe I'll quickly just do that on stream because why not? Let's just do that. Recently, I am switching away from all the Adobe stuff so that I can do stuff locally. So I made like YouTube stuff. Let's create a new page. It will be whatever, overlays. And we're gonna do it this way then. Whoa, I'm zooming in the wrong thing. How can I zoom in? Entire page for the stream, please. There we go. So let's get something like the Zig logo, or maybe Git logo is a little bit simpler, right? Copy, paste it here, and we're just gonna make a simple overlay. So let's delete a bunch of stuff. I know it's a temporary disturbance, but I need something. So let's try to do it where we just have a bunch of text. All right, bunch of text that says, I'll be back or something, right? And Drunken says, example, if I just wanted to know what git push does without reading the whole man pages, I could do TLDR git push. Yep. Let's get just some kind of text on it. Feedback. Be right back. Okay. Something like this. Let's just get a different font. Which font? I like this font here. Was it Montserrat or something? Or Bebe Noia something? Oh, probably the weird Bebe font. Bebas Noia, that's it. Be right back. So we're gonna do it this way. Let's just, I want to do something fancy with it. All right. Maybe we'll just do this. Be right back. I can probably select them all and make, hey, distribute them. Oh, I see. Okay. How do I distribute them? evenly. More actions. Distribute vertical spacing. There we go. So I need to move this one up a little bit here. Come on. A little bit here. There we go. This one a little bit here. Now when I select them all, we'll have distribute this way. And if I'll say distribute horizontal spacing, what the hell is going to happen? Nothing. We do this. We do that. A little bit here. This one can stay in the middle. This one can go somewhere here. And now I can hit distribute this. There we go. Beautiful. So this should be enough. Let me just make it, all the text. We're gonna do some magic here. We're gonna make it white. Where's the color? Color will be pure white. So you can't see it right now, but hopefully I can export it as some kind of PNG, double the thing, and color profile, image, ignore overlapping layers. How do I export it with transparent layer? I don't want. Oh, wait. There we go. Include bounding box, preview. Still shows like that, but I want to see. Export it. And what the hell is going to happen? It's white. Oh no. Cool. Came for the Git lesson, stayed for the Figma tour. Yeah, I'm actually super happy with Figma for YouTube thumbnails. I'm like 10 times faster than doing anything in the Illustrator. Illustrator is just super clunky. Okay, so let's maybe leave it white. Let's make the background black for now. And let's put it in the back inside here. And this way I can use some blending mode and I'll have this just flying around on the screen. So there we go, export it. And this is not YouTube, this is not learning Git. This will be BRB, okay? Export it. I just need to move it. Let me just do that off screen. That goes to streams, and I guess I need to throw in some kind of overlays. There we go. And now in this scary box, I need to figure out how to configure it. So let's add what image? This will be right back. Okay. And then I need to find it, which will be on media, YouTube, overlays, and we have BRB. There we go. You can't see anything now, I guess. Properties. Where's the blending mode? Filters. Come on. Chroma key. Blah, 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 blah. Sharp. Nope. I'm sorry, but where is the blending mode? Color correction, color key. I recall doing that somewhere. I know that in a full camera, right? Right here. Somewhere I can probably move it. Ben loading, I can just move it here. This has blending mode. Properties. Nothing here. Filters. Nothing here. But I made it blend. How'd I do it? Right click. There we go. Hide the mixer, do other stuff. There we go, blending mode, okay. But it's default. Oh, okay, add. Okay, all right. So this goes where it was. I go back to our full screen. Right click this, can't show it. Right click, blending mode, add. There we go. Now we have actual screen, so I can do even more fun stuff. Add scroll. Okay. And we're gonna make it maybe not this, but this. Okay. We're gonna have effect like this. And this should be, I guess, good enough to let somebody figure out that I'll be back, right? So, okay. All right. Things are working the way I want. Good. So I can disable that, and we're back to normal content. All right. We got our break from Git. We can recap. And drunk alcoholic asking, background is a layer which is white. I didn't have anything added, so I mean, maybe in Figma I can edit the frame and change its color. I don't know. I just don't have time to figure that out. Background filled with white, maybe. So yeah, what I did is I made background black and the text white. And what that means is that if I'll do add blending mode, black is like 0. So because it has 0 of red, 0 of blue, and 0 of green, therefore it would add nothing to the image, while something like white color, it will add all the full colors, so it's gonna be basically visible over everything. But in the future, if I want to add some effect, maybe color here and there, I would need a proper PNG. For now, at least I can display something. Okay, all right. So Git basics, getting a Git repository. So this is the area where I was always confused because for some reason I never learned a proper way to set up the Git repository. As in, Git init, it will create a repository for you. I can work on it locally, but I never got to the point where, oh, I'm gonna connect to GitHub now. Somehow. With those remotes, so I never learned that. So I guess probably not here, but eventually we'll learn. Okay, if you can read only one chapter to get going with Git, this is it. This chapter covers every basic command you need to do. You need to do the vast majority of the things you'll eventually spend your time doing with Git. By the end of this chapter, you should be able to configure and initialize the repository, begin and stop tracking files, add, stage, and commit changes. Okay? Okay. We'll also show you how to set up Git to ignore certain files and file patterns, how to undo mistakes quickly and easily, how to browse the history of your project and view changes between commits, and how to push and pull from remote repositories. Okay, so everything will be here. Lovely. Okay, all right. So getting a Git repository. You typically obtain a Git repository in one of two ways. You can take a local directory that is currently not under version control and turn it into a Git repository. Or you can clone an existing Git repository from elsewhere. In either case, you end up with a Git repository on your local machine ready to work. Alrighty, initializing a Git repository in an existing directory. If you have a project directory that is currently not under version control and you want to start controlling it with Git, you first need to go to that project's directory. If you've ever done this, it looks a little different depending on which system you're running. So we'll be focusing on Linux, okay? So let's create a simple directory. I'm gonna go to temp. Let's go to Git, make directory Git, or also make directory. I mean, what the hell? Make Git slash test1. Okay, that's the directory we're gonna do stuff in. Git/test1. There we go. And here we can set up some kind of project, right? I mean, I don't know, npm init. Package name, sure, test1, doesn't matter, and no Git repository, no keywords, no author, no license. Yes, it's okay. So now we have basically package.json and nothing else. We can do something more magical. Let's say we do npm, package.json, right? Let's just add something so that we pull extra file dependencies, and we could throw in something here, something heavy. I know, TypeScript. Is TypeScript installed that way or something? How on earth do I install TypeScript? Is it just TypeScript? Add TypeScript to get to npm project. How to set up package name TypeScript. And that's it, right? Install TypeScript, save dev. Oh, let's actually do that. Sure, why not? No, so npm install TypeScript, save dev. There we go. This will add one package. So if we're gonna package JSON, there we go. We've got everything. We've got our node modules and package log and everything. So now we're gonna go back to our tutorial because we have some extra files, including our node modules, which is probably already a size of a black hole. But we'll learn how to ignore it, right? So for Linux, we go to our project. We're already there and type git init. All right, git init. Initialize empty Git repository in our directory, okay? So if we do lsa, list everything, we get our Git directory. There we go. Our node modules and other stuff is still there. Lovely. Alrighty. This creates a new subdirectory named Git that contains all of your necessary repository files, a Git repository skeleton. At this point, nothing in your project is tracked yet. See Git internals for more information about exactly what files are contained in the Git directory you just created. We'll get there in time. If you want to start version controlling existing files as opposed to an empty directory, you should probably begin tracking those files and do an initial commit. You can accomplish that with a few git add commands that specify the files you want to track, followed by git commit. So git add everything.c, git add license, git commit initial this. So we'll go over what those commands do in just a minute. At this point, you have a Git repository with tracked files. So let's do that. We're gonna add our package lock and package.json. So let's try that. Git add. The thing is, if I'm gonna do everything.json, will it try to include stuff from inside node modules? Normally, I wouldn't think so, but I don't trust it yet, so I'm just gonna say package lock JSON. Okay, and package.json. Okay, we added them. Git commit m as in from message, I believe, initial project version. Okay, enter. Main root commit, I guess because it's our first ever commit. Initial project version. 2 files changed, 44 insertions, and there we go. Perfect. So cloning an existing repository, that's an alternative, right? If you want to get a copy of an existing Git repository, for example, a project you'd like to contribute to, the command you need is git clone. If you're familiar with other VCSs such as Subversion, you'll notice that the command is clone and not checkout. This is important distinction. Instead of getting just a working copy, Git receives a full copy or nearly all data that the server has. Every version of every file for the history of the project is pulled down by default when you run git clone. In fact, if your server disk gets corrupted, you can often use nearly any of the clones on any client to set the server back to the state it was in when it was cloned. You may lose some server-side hooks and such, but all the version data would be there. See Getting It on a server for more details. So you can clone a repository with git clone URL. For example, if you want to clone a git linkable library created libgit2, you can do so like this. So let's try it. Let's just go back to our temp git and do, I don't know, git clone https github.com, and let's do, I don't know, xconti/surreal.nim. Right, enter, bam, clone, and we go to surreal.nim, and we've got all the fun files. Beautiful. Oh wow, they even have a special icon for nim. That's so awesome. I did not expect the nerd fonts to actually have nim logo in there. Okay, so it's that simple to, clone repo, create new something. It's still a little bit of typing to add some files to be tracked or whatnot, but not too bad. Okay, that command does the same thing as the previous one, but the target directory is called mylibgit. Oh, so we can also specify which directory. Oh, that's so awesome, because I just never bothered checking. But it's often a situation where I'm already here, right? And you made directory, I don't know, surreal, maybe -nim, because that's where I want to work, right? You go into surreal.-nim, you're here, and you're like, oh, I'm gonna check out this nice repo that I wanted, right? And you're gonna do that. Oh, and I have it as a subdirectory. Let's move everything. But if I can just put period to just clone it here, LSA. Whoa, what happened? Yeah, I just have it here. Perfect. Oh, that is so nice. And this will be the surreal-nim. We only want one copy. Alrighty. Awesome, is that simple. The command does the same thing as the previous one, but the target directory is called mylibgit. Git has a number of different transfer protocols you can use. The previous example uses the HTTPS protocol, but you may also see the git / or user at server and a path to repo, which uses the SSH transfer protocol. Getting Git on a server will introduce all of the available options the server can set up to access your Git repository and the pros and cons of each. Okay, so we'll learn still something about how to use Git. Even when we're just setting up the server, we'll just learn the other end of the story, and I guess things will make a little bit more sense. Okay, this was already informative. I very much like this book, and it goes fast too. All right, so Git basics, recording changes to the repository, all right? At this point, you should have a bona fide Git repository on your local machine. And Drunk Alcoholic wanted to send something, and it didn't show up. Probably a link or something. For some reason, Google just, I don't know, removes everything. And I know so little about dealing with all this stuff that I don't even know how to enable stuff. Try to send an icon. Okay, I see. I mean, if I'll try to copy this, what's going to happen? I paste it and it's just an empty character. Yep, Google just makes it disappear. That's fun. Yeah, that's fun. Funny. Oh well. No nerd fonts in the chat. That's all. All right. So we have a Git repository and check out a working copy of all its files in front of you. Typically, you'll want to start making changes and committing snapshots of those changes into your repository each time the project reaches a state you want to record. Remember that each file in your working directory can be one of two states, tracked or untracked. Tracked files are files that were in the last snapshot, as well as in any newly staged files. They can be unmodified, modified, or staged. In short, tracked files are files that Git knows about. Untracked files are everything else. Any files in your working directory that were not in your last snapshot and are not in your staging area. When you first clone a repository, all your files will be tracked and unmodified because Git just checked them out and you haven't edited anything. Okay. All right. As you edit files, Git sees them as modified because you've changed them since your last commit. As you work, you selectively stage these modified files and then commit all those staged changes and cycle repeats. So we have an untracked file, we add the file, therefore it becomes staged because we staged it, yeah. And if it's unmodified, we need to edit it, and when it's modified, then we can move it to staging area. And if the file is unmodified, we can remove as an untracked file. And yeah, and that's it. Alrighty, but if we remove the file as an untracked, it will also, I believe, go to staged as the deletion of the file, I believe. Okay, so checking the status of your files. The main tool you use to determine which files are in which state is the git status command. If you run this command directly after clone, you should see something like this, git status. So before we continue, let me use, what was it, ZellyJ? There we go. Wow, what's new and everything? Web client, multiple pane select, key tooltip, holy moly, stack key binding, performance improvements. Great. I'm gonna use ZellyJ to kind of have stuff. So let's do new pane. That will open a pane like that. We don't want that. Control G. How do I remove that? What are the other options? Oh, there we go. I need to learn this because, we can click. Look at that. How fun. Pane, closed. There we go. I want not a pane. I want a tab. Control G, tab, new. Control G, tab, rename. Rename. Okay, so second one will be maybe Mirvim. Okay. Alt 1 or something. How do I change them? Not with Alt. G T move, close, rename. G1? No, how the hell do I change tabs? I mean, I installed it basically because I don't use this kind of stuff too often. And this has all the shortcuts, so looks like I can't learn shortcuts either. Toggle, okay, toggle and enter, select. Oh, just with arrows, ew. Can I do with, okay, I can do that, and enter is to select. So it'll be not this one. Control G, rename. This one will be our Git. Nope. Control G, tab, rename, Git. There we go. And then we have a last tab, which will be our shenanigans. Tab, new, tab, rename, shenanigans. Okay. And they are all in the same repository. Okay. So in our Git, we can do git status, right? Fatal, not a Git repository. Oh yeah, we need to go to test 1, right? And run git status, and on branch main, untracked files. The node modules is untracked currently, okay? And we want it to stay that way. We don't want to touch it. Let's just go to the pane tab, the right. Okay, and we're gonna do, what is it? Test 1. What the hell? Bad match expression, operator expected. Let's ignore that. Let's open this up in the Vim so that we see things. And then at last, we're gonna go to the right, and then shenanigans. We're gonna go also temp 1. And I'm in here. Test 1. There we go. Did I screw up the previous one? Yes, I did. No, we are good. Ignore me. I'm just a confused person in general. GT here. Okay. I don't like the tab switching. I would like it to be quick thing. I don't like that Alt is for switching panes, and I can't do like Alt 1, 2, 3 to switch between those. I mean, I can click on them, but that's like non-keyboard thing. And the Drunken says, Kitty Terminal has panes built in, might worth looking in the future, makes it easier to get panes, in my opinion. Yeah, but if I'm gonna connect to SSH, I'm not gonna get those features. I have this purely for SSH because other than that, in Hyperland, I can just switch stuff, and, I can, with keyboard, do stuff. Oh, I need to open files. I just do here. I need to move it somewhere. I can move stuff around, no problem, right? Even to a different screen or whatever, because I have like 10 screens or on whatever, 10 virtual desktops for each monitor and stuff. So I really like Hyperland. So on a computer locally, I have everything. Normally, I don't have to run ZLJ, but for something like now where I would like to have this screen where we keep reading that, we have a few different terminals here, it might be good. Or through SSH. Because often I'm doing some kind of work on a computer and then gonna go to a different room and continue on the laptop. All right. So we check the Git status, right? It says we're on a branch main. We have untracked files, which is node modules. Nothing added to commit, but untracked files present. Okay. This means you have clean working directory. In other words, yeah, because they don't have node modules. None of your tracked files are modified. Git also doesn't see any untracked files, or they would be listed here. Finally, the command tells you which branch you're on, informs you that it was not diverged from the same branch on the server. For now, the branch is always master, in our case main, which is the default. You won't worry about it here. Git branching will go over branches and references in detail. So note, GitHub changed the default branch name from master to main in mid-2020, and other Git hosts followed suit. Okay, so this book suggests that either it was updated since then, or it was written after 2020. Interesting. So you may find that the default branch name in some newly created repositories is main and not master, In addition, the default branch name can be changed. So you may see different name for default branch. However, Git itself still uses master as the default, so we will use it throughout the book. Interesting. I had it pre-configured to be main. Maybe that changed? Let's say you add a new file to your project, a simple README file. If the file doesn't exist before and you run git status, you'll see untracked changes. Okay, so let's go to new vim and new? How the hell do I add new files here? Space, Explorer, code. Oh no, okay. Touch, readme.md. There we go. Now we should have it here. I forgot how to create new file new vim. Ay. I should be ashamed of myself. Okay, so in README, we can just do something like header. What is going this test project to be? I know. Diff web display. Okay. This project allows you to display the changes made in your working directory on a locally hosted web server page, whatever. That's it. All right. We just write it, and in our git status now, we see that we have untracked README as well as enrolled modules. All right. Cool. So just like they showed, they have README. You can see that your new README file is untracked because it's under the untracked files heading in your status output, right? Untracked files. Untracked basically means that Git sees a file you didn't have in the previous snapshot commit and which hasn't yet been staged. Git won't start including it in your commit snapshots until you explicitly tell it to do so. It does this so you don't accidentally begin including generated binary files or other files that you did not mean to include, like maybe your environment files, right? You don't want to include that. You do want to start including README. So let's start tracking the file. So tracking new files. In order to begin tracking a new file, you use the commit git add. To begin tracking the README file, you can run this, git add README. So we do git add README md, enter. There we go. So when we run git status now, we see that we still have the untracked files, but above it we have changes to be committed. I guess this is our stage, right? New file, README. Okay. The same thing, changes to be committed. You can tell that it's staged because it's under the changes to be committed heading. If you commit at this point, the version of the file at the time you run git add is what will be in the subsequent historical snapshot. You may recall that when you run git init earlier, you then run git add files. That was to begin tracking files in your directory. The git add command takes a path name for either a file or a directory. If it's a directory, the command adds all the files in the directory recursively. All right. So here's staging modified files. Let's change a file that was already tracked. If you change a previously tracked file, call contributing.md and then run your git status command, you get something that looks like this. So let's do that. In our new vim, we're gonna go to our package.json and we're gonna change, I don't know, the name will be something like, what was it? diff web viewer. Okay, there we go. Version will be what the hell? Will be, come on, cooperate please. 0001. All right. So we get back to our Git and run the status. We see that we start with changes to be committed. It's still README. Then we have changes not staged for commit. We have modified package.json, and we still have our non-tracked files there. Okay, there we go. So they're showing the changes to be committed for them is the same, and not staged for commit is modified. The contributing MD file appears under a section named changes not staged for commit, which means that a file that is tracked has been modified in the working directory but not yet staged. To stage it, you run the git add command. Oh, just the same command, right? Git add is a multi-purpose command. You use it to begin tracking new files, to stage files, and to do other things like marking merge conflicted files as a result. Oh. It may be helpful to think of it more as add precisely this content to the next commit, rather than add this file to the project. Let's run git add and now to stage the contributing MD file and then run git status again. All right, so we're gonna do git add package.json. There we go. And git status. And we see that changes to be committed are now new file readme and modified package.json. Beautiful. Just like they have that same. Both files are staged and will go into your next commit. At this point, suppose you remember one little change that you want to make in contributing.md before you commit it. You open it again and make that change, and you're ready to commit. However, let's run git status one more time. Awesome, that's exactly what I wanted to do. In my case, I want to go to edit the readme again. Okay. And maybe I remember, you know what? I want to add something here. Maybe text stack. It'll be for now node, whatever. It will be just a list with node.js. Okay, that's the only thing we have for now. For some reason, you need to keep track of it. Write it. And now git status, notice this. Changes to be committed, we have a new file readme and package.json. But we also have still modified readme again, so we have it twice. So the way I understand it, before we read what it really means, is that the moment we added the file to the staged area, it kind of took a snapshot of the version. We copied this file to that staged area and it exists as that version of the file there. Therefore, when we modify our local file on the computer, we modify a different version of it, like the local one. So basically git add is like, hey, copy it to the staging, not link it in any way. It's just copy the data. So, however, git status one more time. So they have the same changes to be committed, but changes not staged for commit, modified, contributing. What the heck? Now contributing MD is listed as both staged and unstaged. How is that possible? It turns out that Git stages a file exactly as it is when you run the git add command. If you commit now, the version of contributing MD as it was when you last ran the git add command is how it will go into the commit. Not the version of the file as it looks in your working directory when you run git commit. If you modify a file after you run git add, you have to run git add again to stage the latest version of the file. Okay, let me see if I can visualize it in a different way. Let me see something. Do I have it here? Yes, I do. Let me just do this. I'll be right there with you. This was our temp git test 1. All right. There we go. So I can go maybe to this screen, and here we have Git Kraken, okay? So we can see that we have 136 unstaged files. So these are all the node modules, the stuff that's untracked. But we see that we have staged files too. We have the README, and it shows us that, hey, we added the diff web display, so we basically added the whole thing. We have big plus that this is an absolutely new file. So this is literally the same thing as Git shows us in command line, just in a visual way. And package.json shows up as modified because we initially created the commit, but we have changes. Test1 was renamed to diff web viewer, and version was renamed to 001. Okay, we can even show the files side by side to see that previously it was that, and we remove those lines and replace them with those 2 lines. Okay, with README we have only the new one because the file previously didn't exist. And the unstaged files, README shows up as because remember, README was added as a brand new file. We haven't committed it at all yet to the repository. It's just in staging as added. But here in unstaged, it shows as modification. And it shows that modification from what is in our staging area to a situation where we added this thing. Okay, so that's how I'm used to look at it. And that's why I have like strong intuition about the 2, because I can quickly preview it with a, nice interface that I can click and see stuff instantly, right? It's nice and fast, and I don't need to run in commands. And we even see the history that our initial project version was here, where we added package.json and the other log file, whatever. But going back here, all right. So, like it is said, if you commit now the version of that was, added with the git add, that's what gets staged and therefore will be actually committed. Okay, so if you modify a file after you run git add, you have to run git add again to stage the latest version of the file. Okay, so git add contributing, and when we do git status, it'll all go here. So we can do git add. We modified README. Bam, added. So git status. There we go. We can see that we have only changes to be committed, this and that. We don't have any stuff here anymore. So if we're gonna go to this screen, you can see that we no longer have the README file here. I'll do this so it's easier to read. Our README is one thing, okay? So yeah, that's awesome. So now we have short status. While the git status output is pretty comprehensive, it's also quite wordy. Git also has a short status flag, so you can see your changes in a more compact view. If you run git status s or git status short, you get a far more simplified output from the command. Ooh, that's fun. So let's see. Git status s. And we have added README Markdown, modified package.json, and question mark for node modules. So we see it as added, and it shows up as a green, and M for that shows up as modified. And let's see their output. M README modified, MM rake file. So maybe we'll get that thing, MM. Is that, because looks like, oh, I see. So probably the first letter here on the left will be our working directory, while the second one will be staging. So we'll see the files in different states. So new files that aren't tracked have a double question mark next to them. New files that have been added to the staging area have an A modified. Files have an A. Modified files have an M, and so on. There are two columns to the output. The left-hand column indicates the status of the staging area, and the right-hand column indicates the status of the working tree. Oh, so left side is staging, right side is working tree. Interesting. Yeah, so we have both. This one is on the left, so it's added to the working tree, modified in the working tree. So if I'm gonna go and modify our whatever markdown thing and do, I don't know, JavaScript, or let's do TypeScript. Okay, and we're gonna do write it, and we're gonna run the same command. We should see now that, let me just do maybe this and run it so it's easy to see. On the left, we have staging, so it's still just added and modified, while here is also modified in a working directory, which is the right side. On the package.json has no changes on working directory, and of course, non-modules is, excuse me, just new. All right. So what I'm gonna do is git add our readme again, and this should get back to normal. There we go. Okay. So, for example, in that output, the readme file is modified in a working directory, but not yet staged. There we go. Staged is nothing. Staged doesn't know about the existence of readme. While the lib simple git rb file is modified and staged. So it's modified and staged. So working directory has no difference compared to staging. The rig file was modified, staged, and then modified again. So there are changes to it that are both staged and unstaged. Yep, double M. Okay, then we have ignoring files. Often you'll have a class of files that you don't want Git to automatically add or even show you as being untracked. Exactly. These are generally automatically generated files such as log files or files produced by your build system. In such cases, you can create a file listing patterns to match them named .gitignore. Here is an example of a gitignore file. Everything ending with either O or A. Everything tilde? The first line tells Git to ignore any files ending in .o or .8 object, and archive files that may be the product of building your code. The second line tells Git to ignore all files whose names end with a tilde. Oh, so basically match any characters and tilde at the end, which is used by many text editors such as Emacs to mark temporary files. You may also include log, temp, or PID directory, automatically generated documentation, and so on. Setting up a .gitignore file for your new repository before you get going is generally a good idea, so you don't accidentally commit files that you really don't want in your Git repository. I actually saw many large existing applications that actually, had Git repository with hundreds of files, like, years of history, yet never established gitignore. And there was just so much junk in there, or people were working with just constantly having this untracked stuff in your face. So I don't understand why. Somehow it's possible. And Ranko says, yep, and API keys get leaked. It's just how you don't know about gitignore. Like, you have 30 people working here. Nobody knows that their .gitignore file should exist. What the hell? So, that's the first thing you create, like right before even creating README. So we're gonna create one. All right. Again, I don't remember how to add any of them. So touch .gitignore. Okay. So in my case, I want to go to hidden items. Really? How do I show hidden items? Dot? No. What is Scratch? G? Toggle comment, toggle case. I don't care about that. No. E? No. H for hidden? No. Oh no. How did that work? Did this little panel on the side? Explorer? It would just toggle it, yeah. And I have nothing else here. Don't know. So I guess we're gonna do, what was it? Space dot git ignore. Nope. Everything's hidden. Seriously. What is this? Vim dot git ignore. How about that? So what we're going to want to ignore is Drunken says A maybe for add. Possibly A. Enter name of a new file directory. Okay, you guessed it correctly. Now I just don't know how to. What is his name? Neotree. Neotree shortcuts and Vim or whatever. Key bindings. To manage the thing, do we have like a default shortcuts here or something? Examples. Of course we won't get that. This uses LazyVim, right? LazyVim. Getting started. And LazyVim has key maps and even Tricitor. Where is Neotree? Oh, that's Chasmois as well. Interesting. No. Neotree? No. Tree? Nope. Plugins. Editor? UI? Seriously? Neotree. There it is, Neotree. Where on earth is this? Extras. Oh, besides plugins, we also have extras. And it doesn't provide any key bindings. Because why would it? Mappings, L, open, H, close, Y, O. And that's it. Why is life like that? Shift H says master drunk alcoholic. All right, thank you so much. This makes me upset. Alrighty. We are doing. Yeah, so we want everything in node modules. So we do node. Was it underscore modules? Yes, node underscore modules. And I think this is enough to ignore everything. Let's write all and let's look at our Git status. Look at that. Our node modules disappeared we have our git ignore for now. So we can do, let's just see if this book tells us to add git ignore. We'll see. So let's see. The rules for the patterns you can put in the .gitignore file are as follows. Blank lines or lines starting with whatever pound are ignored. Standard glob patterns work and will be applied recursively throughout the entire working tree. Okay. You can start patterns with a / to avoid recursivity. Ooh. You can end patterns with / to specify a directory. Okay, so in our case, we would want to add that we only care about the directory. Okay, just ignore all the directory. And I guess because they will be recursive, this means that even if some subfolder has node modules, they'll be ignored as well. And you can negate a pattern by starting it with an exclamation point. Okay, so if I would do exclamation mark node modules, I guess everything but node modules will be ignored. Alrighty. So what time is it? Okay, alright. We still have a bit of time. Glob patterns are like simplified regular expressions that shells use. An asterisk matches 0 or more characters. ABC matches any character inside the brackets, in this case A, B, or C. A question mark matches a single character, and brackets enclosing characters separated by a hyphen matches any character between them, in the case 0 through 9. You can also use 2 asterisks to match nested directories. So A /*/z would match, for example, A to Z or ABZ, ABCZ, and whatever we have inside. Here is another example, .gitignore file. So we have the comments like ignore all .a files, but do track lib.a, even though you're ignoring .a files above. Oh, so that's how we do it. We say, oh, don't ignore this one, right? So this is literally don't ignore and what it is. So if we would do exclamation mark node modules, it's not like it would inverse entire stuff how it's ignored. It's just say, hey, don't ignore node modules, right? And then we have only ignore the to-do file in the current directory, not subdirectory /to-do, right? So this means basically in a root directory, ignore to-do. Ignore all files in a directory named build. Okay, ignore doc/notes.txt, but not doc-server-arch.txt. So doc/ everything like that. Okay, so that basically means that inside the doc directory, we need instantly any txt files. We won't do that. We won't fit any other thing unless we do exactly this: ** and then any directory, because this matches to any directory in between or none of them. Okay, great. Tip: GitHub maintains a fairly comprehensive list of good .gitignore file examples for dozens of projects and languages at https://github.com/github/gitignore. Okay, yeah, I think I used that before. If you want a starting point for your project. And note, in the simple case, a repository might have a single .gitignore file in its root directory, which applies recursively to the entire repository. However, it is also possible to have additional .gitignore files in subdirectories. The rules of these nested .gitignore files apply only to the files under the directory where they are located. Yep, the Linux kernel source repository has 206 .gitignore files. It is beyond the scope of this book to get into the details of multiple .gitignore files. See man gitignore for the details. Yeah, so I mean the common case is, let's say you have one repository for like your, like on the other streams, I'm making the the tracker, right? So let's just quickly go to whatever, to main directory, repos, and this was habit tracker, right? When I look here, we have this is our main Git repository. We have the Git directory with all the Git related stuff. We have our README license, and then we don't have any .gitignore, right? We could have a .gitignore file here because maybe we had something here, some settings that are shared between the projects or whatnot, and they would be to be ignored. So it will live here and will apply to everything, both the front end and the back end. But if I'm going to go into the back end and list files here, you can see that I have gitignore file here. So it would apply only to everything without the backend, because this is very project specific, right? This is a Dart file. So if I'm going to display it, I don't know. I could just do cat gitignore. You can see that it's the store, Dart tool, packages, right? All those things that totally don't matter to whatever we have in our front end, right? Because here we also have gitignore, but it's vastly different because it's a different technology. It cares about different files and whatnot. So yeah, that's that. And for some reason, even though this is a what do you call it? Node.js solution, it tries to ignore solution.suo. These are like C# and Microsoft stuff. So this is surprising to see here. But hey, that's what was defined by default. So let's go to our temp git temp1 test 1. There we go. All right, we're back where we're supposed to be. Alrighty, so viewing your staged and unstaged changes. If the git status command is too vague for you, you want to know exactly what you changed, not just which files were changed. You can use the git diff command. We'll cover git diff in more detail later, but you'll probably use it most often to answer these two questions. What have you changed but not yet staged? And what have you staged that you are about to commit? Although git status answers those questions very generally by listing the file names, git diff shows you the exact lines added and removed, the patch as it were. Okay. Let's say you edit and stage the README file again and edit the contributing.md file without staging it. If you run your git status command, once again, you'll see something like this. Right, on branch master, we have changes to be committed, for example, README, and changes not staged for this commit, just contributing MD, right? To see what you changed but not yet staged, type git diff with no other arguments. So git diff. So in our case, we can actually run that because if we're gonna do git status, we can see that, we have untracked gitignore. Will git diff work here? Probably not. Because we don't have anything yet. So let's say that we're going to change our README file again and maybe add extra technology, which will be web browser. Okay. I know it's outrageous and doesn't make any sense, but we added that little line. Okay. And maybe we're going to say that this project allows you to display. So maybe instead of allows, we're gonna do what my wife often tells me, to stop saying allows and start using lets, right? This project lets you, because I usually talk like a robot. So we'll say that. So we have two changes. We changed the lets and we added the web browser. So now I can get back to our Git. We'll see that, we did diff, status. We can see that our README file, it's staged, but also modified. where it's not staged yet. So when we write git diff, we see we have a diff of the README file from A to B. And we have some checksums or whatnot, A and B. Okay, so whatever was on A is removed, and then here additions. I guess this should maybe list like on average how much was being done. I don't know. This is interesting what it means. So we can see that we removed this line and we added this line. So this is the thing I don't like about Git on command line, that I don't see what exactly changed here. I need to track the whole thing. If I'm gonna go to here and look at README, at least I can see here, the LEDs is highlighted. You know, the whole line is kind of reddish, but I can see that allows is a little bit more highlighted, and LEDs is a little bit more highlighted. So it shows me, oh, in this line, only this part has changed. So I don't need to go and hunting for the thing here. And also the web browser was added. Lovely. So to see what we've changed, but not yet staged, type git diff with no other arguments, okay? And here's the same thing. The command compares what is in your working directory with what is in your staging area. The result tells you the changes you've made that you haven't yet staged. Exactly. Because remember, the README hasn't been checked in yet at all. It's just in staging forever as an added new file. Yet we see modifications to it from working directory. If you want to see what you staged and what will go into your next commit, you can use git diff staged. There we go. So git diff -- staged. And suddenly we have way more. So this is git diff staged, okay? We see this stuff, new file, mode, and index, whatever. So we see that this was added. Entire new file, readme nd, all is added. But it still has allows and still doesn't have the web browsers here because that hasn't been staged yet. And then we have package.json. We can see that we initially submitted it, but this commit will basically change those two values. And that's pretty much it. It's important to note that git diff by itself doesn't show all changes made since your last commit, only changes that are still unstaged. If you've staged all of your changes, git diff will give you no output. For another example, if you stage the contributing MD file and then edit it, you can use git diff to see the changes in the file that are staged and the changes that are unstaged in your environment. Looks like this, right? So we have git status, changes to be committed, modify contributing, and changes not staged, again, contributing. Now you can use git diff to see what is still unstaged. Yep, and it shows that test line was added. And git diff cached to see what you've staged so far, which is staged and cached are synonyms. Oh, okay. That's interesting. So now we know that if by any chance we see cached, it means staged. Okay. And we see all this stuff. So yeah, that makes sense. Git diff in an external tool. We will continue to use git diff command in various ways throughout the rest of the book. There is another way to look at these diffs if you prefer a graphical or external diff viewing program instead. If you run git diff tool instead of git diff, you can view any of these diffs in software like Emerge, Vim diff, and many more, including commercial products. Run git diff tool will help to see what is available on your system. Oh, I'm curious. Git diff tool and do tool help. Whoa. So git tool may be set as one of the following: Araxis merge, NeoVim diff, VS Code, okay, BC, which is beyond compare. The following tools are valid but not currently available. Oh, all right. So I have basically VS Code, NeoVim diff, and whatever Araxis is. some Araxes merge, interesting. But I could use beyond compare, and there are several versions: code compare, delta walker, diff merge, diffuse, EC merge, emerge. Oh my, there's plenty. Meld, open diff, perforce merge, smurge. Okay, so there are some tools, right? So what if I'm gonna run git diff tool? Which one will show up? This message is displayed because diff tool is not configured. See git diff tool to help, or git help config for my details. Git diff tool will now attempt to use one of the following tools. Okay, basically any of them. No known diff tool is available. Wow, okay. Launch? Yes. And no. External diff died. Stop reading. Okay, never mind. I would need to configure the tool, right? Commenting your changes. Now that your staging area is set up in a way you want it, you can commit. It's not the way we want it because we go to status. Git status S. We see that we need to still add our readme and .git ignore. So git add readme to have that extra change, and git add git ignore. And another thing, it's possible to commit while still, everything that's in staged, while still having stuff in a working directory that's different. That's the whole idea. Okay, so now we run it again, and it's all nice and clean. It doesn't complain about node modules being there, right? Wait, I ran the same thing twice. Status, please. There we go. Okay, remember that anything that is still unstaged, any files you have created or modified that you haven't run git add on since you edited them, won't go into this commit. They will stay as modified files on our disk. In this case, let's say that the last time you ran git status, you saw that everything was staged, so you're ready to commit your changes. The simplest way to commit is to type git commit. Doing so launches your editor of choice. Ooh. So this is set by your shell's editor, environment variable, usually Vim or Emacs. Although you can configure it to whatever you want, so we did set it to NeoVim. Okay, the editor displays the following text. This example is a Vim screen. Please enter a commit message for changes. Line starting with pound will be ignored, and an empty message aborts the commit. Okay. On branch master, your branch is up to date. Also, it even gives us stuff, and we can basically add stuff here or something. Whatever it is. Excuse me. You can see that the default commit message contains the latest output of the git status command, commented out, and one empty line on top. You can remove these comments and type your commit message, or you can leave them here to help you remember what you're committing. For an even more explicit reminder of what you've modified, you can pass the -v option to git commit. Doing so also puts the diff of your change in editor so you can see exactly what changes you're commuting. So let's try the git commit -v. Git commit -v. Look at that. So open up NeoVim. We can see that we have our empty line to, I guess, put in our title, which will be whatever. Define project and add git ignore. Okay, we just added that. So this will be our first line. I already know that the first line is the title, and then whatever lines are after that will be your description. So I can imagine this will be fun because we can actually go through our diff. It's all this stuff, whatever. Everything below it will be ignored. Okay, so I thought that maybe this will be all commented out and I can just start adding here, but not really. Too bad. But we have this fun little scissors stuff that is gonna cut off everything. Okay, All right, so I guess that's it, right? When you exit the editor, Git creates your commit with that commit message with the comments and diff stripped out. So what I do, can I write everything? I can. Can I quit all? There you go. Define project and add .git ignore. 3 files changed, 12 insertions, 2 deletions. Created the git ignore and created the readme because they were untracked before, so they're new files. Okay. Alternatively, you can type your commit message in line with commit command by specifying a -m flag. Excuse me. Like this. Git commit m, and then we pass in the string. Now you've created your first commit. You can see that the commit has given you some output about itself. Which branch you committed to master. In my case, it's showing that we committed to main. What SHA1 checksum the commit has, in this case, this thingy, and how many files were changed, and statistics about lines added and removed in the commit. Remember that the commit records the snapshot you set up in your staging area. Anything you didn't stage is still sitting there modified. You can do another commit to add it to your history. Every time you perform a commit, you're recording a snapshot of your project that you can revert to or compare to later. Alrighty, skipping the staging area. So we just added that. We have everything. And I look into Git Kraken. You can see that, hey, we already have our commit in place. This is exactly what happens. And we don't have anything like above it that will suggest that we have any waiting changes. Alrighty. So we'll be finishing soon because this is a lot of talking for me today. I need to let my throat, regenerate. So I guess we're gonna finish after this. Skipping the staging area. Although it can be amazingly useful for crafting commits exactly how you want them, the staging area is sometimes a bit more complex than you need in your workflow. If you want to skip the staging area, Git provides a simple shortcut. Adding the -a option to the commit command makes Git automatically stage every file that is already tracked before doing the commit. Okay, letting you skip the git add part. All right, I can see that working. So if you have a habit of always doing a little change, making sure it looks good, okay, committing in small parts, awesome. So git status, we can see that we have changes not staged, nothing staged, right? So this is not in staging, and we modify contributing MD, and that's it, right? We just made that one change. We don't care about anything. We just do git commit, all of them, and message this. And just we skip the staging at all. Notice how you don't have to run git add on the contributing MD file, in this case, before you commit. That's because the -a flag includes all changed files. This is convenient, but be careful. Sometimes this flag will cause you to include unwanted changes. But at least it doesn't add the untracked stuff, right? So if you create a new file, you still need to add it to staging. And I guess because you're forced to add to staging, you can't do -a because that will probably ignore staging. Yeah, that's the question. If you already have stuff in staging, will -a, I guess that -a what it does is really behind the scenes adds all the changed files to staging and then commits. Yeah. That's how I would assume it works. Okay, removing files. To remove a file from Git, you have to remove it from your tracked files. More accurately, remove it from your staging area. And then commit. The git rm command does that and also removes the file from your working directory so you don't see it as an untracked file in the next time around. Oops. If you simply remove the file from your working directory, it shows up under the changes not staged for commit. that is unstaged area of your Git status output, okay? So if we're gonna go to Git status, we'll be seeing deleted. There we go. Then if you run git rm, it stages the file's removal. Okay, because not stage. We do git remove instead of git add, right? And changes to be committed is to delete this file. The next time we commit, the file will be gone and no longer tracked. If you modified the file or had already added it to the staging area, you must force the removal with the F option. So if you've modified the file already, added it to the staging area, you must force the removal with the F option. Okay, so this is a safety feature to prevent accidental removal of data that hasn't yet been recorded in a snapshot and that can be recovered from Git. Okay, that makes sense. We just do remove F, force. Another useful thing you may want to do is to keep the file in your working tree, but remove it from a staging area. Exactly. In other words, you may want to keep the file on your hard drive, but not have Git track it anymore. This is particularly useful if you forgot to add something to your .gitignore file and accidentally staged it, like a large log file or a bunch of .a compiled files. To do this, you use the -- cached option. So git removed from the staging readme. Okay, you can pass files, directories, and file glob patterns to the git remove command. That means you can do things such as git remove, log / and everything ending with a log in there. Note the \ in front of the star. This is necessary because Git does its own file name expansion in addition to your shell's file name expansion. Okay, so it's complicated. This command removes all files that have the .log extension in the log directory. Or you can do something like this: git remove, and everything. Yeah, again, we escape the star that ends with tilde. This command removes all files whose names end with tilde. Alrighty. So this is something that we'll need some practice with eventually. I feel I'm running out of steam, so we'll ignore it for now. Maybe we'll do it during next stream. Maybe tomorrow we'll continue with Git. We'll see. Moving files. Unlike many other VCSs, Git doesn't explicitly track file movement. If you rename a file in Git, no metadata is stored in Git that tells it you renamed the file. However, Git is pretty smart about figuring out after the fact. We'll deal with detecting file movement a bit later, okay? Thus, it's a bit confusing that Git has a move command. If you want to rename a file in Git, you can run something like git move file from to file 2, and it works fine. In fact, if you run something like this and look at the status, you'll see that Git considers it a renamed file. Renamed. Bam. However, this is equivalent to running something like this. Move readme to here. So the same as in your command, and then git remove readme md and git add readme. Okay. Git figures out that it's a rename implicitly, so it doesn't matter if you rename a file that way or with the move command. The only real difference is that git move is one command instead of 3. It's a convenience function. More importantly, you can use any tool you like to rename a file and address the add remove later before you commit. Perfect. Okay, so the next chapter will be basically viewing the commit history. So that's what we're gonna resume with next time. I'd say I'll try to stream tomorrow. I can't guarantee that. I know that in the morning we stream more React and Dart, but I just don't know if I'm gonna squeeze, a second stream tomorrow. So we'll see how it goes. And yeah, I mean, so far we learned a lot. Actually, I did more with command line today than I guess I did ever. So that's very exciting. And yeah, I'm looking forward to learning more because we'll be viewing commit history. And after that, we're gonna go undoing things and maybe work with remotes, right? So that's where we're gonna start using actual GitHub. Wow, we have tagging everything. This is gonna go fast, right? So viewing history will be next time. And yeah, so I hope that whoever was watching, that you learned something just like I did. And thank you for watching. And Drunk Alcoholic, thank you for hanging out with me and helping out. So see you next time.